Today we've got Dono with us, who's going to be running through his experience with shift left testing, and he'll give you an insight into his experience, how they've been implementing that through his work, and also he'll open up at the end for any questions that you guys have on that. He's going to be using Slido for that, so you can go to slido.com or slide.do, or scan the QR code there to ask any questions on that format. He's got the code there as well. I'll drop that into the Zoom chat function so you can see that as well. Yeah, I'll pass over to Dono now. Any questions, just drop them over to Slido. Dono, over to you.
Cool, thank you, man. Yeah, so as Ash was saying, join Slido, throw questions there as you go, and then I will pick them all up at the end of the talk. And just as we talk about it, homeworking, all of that, daughter's knocking on the door. Right, let's get cracking on with the presentation. Right, so shift left testing, it's all about delivering better quality software faster. So things. One second, Alani, downstairs. Right, so a bit about me. So I started out as a QA. I'm very passionate about the subject. I call myself a quality evangelist. But however, we've been truthful about the whole side of things. Really, what we do as a QA function is we deliver software. We used to be considered as the gatekeepers in the old waterfall approach side of things. As we go into agile, we're starting to still be gatekeepers, but more in the case of we're there to actually put in place gates to allow us to get through a software delivery cycle. So with that, I've taken a positive change in my title to make it more relevant, to be head of software delivery. And it just allows the message and the imagery of that to come a little bit clearer. And it shows that it's not just around testing, and we're not just there as testers, but we're actually there to help deliver software with the engineering teams. So yeah, moving on. Right, so with the mentality of Olympic gold medalist, we work hard through the tough bits so we can be the fast that eats the slow. So this is a nice amalgamation of two quotes that I've put together to make my own. Plagiarism is best. But essentially what it means is it's not the big that eats the small. That used to be the case with old legacy companies and that side of things. However, it's actually whoever can get to market fastest or make the impact faster than their competitors to then steer customers away, they will be the ones that will start growing faster in that space. And the more you do that, the more you grow as a company or taking up the market share. So doing that, how do we do it? Well, we break it fast and we fix it fast. This is what Agile was always meant to be, allow us to do things faster in smaller iterations to continually improve, getting that very quick feedback. However, there's a common misunderstanding of this, that the quality of things have to suffer for it. And that's really not the case. It doesn't need to be. If you keep with old legacy ways of doing things, it will, but there are definitely ways and methods you can do to make sure that your quality bar is actually high from the start, and therefore your quality is not suffering at all. So yeah, as I was saying, first to market, you definitely have a massive advantage. So what we can do here is we can shift left to reduce our costs, get higher efficiency, set a higher quality bar, and make sure that we have that competitive advantage, not only in speed and being the first one there for the consumers, but also we can also be the best out there at the same time. And that's the sort of nirvana of this whole approach. If you can be the fastest with the best solution, you're absolutely hitting it nail on head. So yeah, how do we solve this? Well, the really short answer to that is we reduce the wasted effort. So when we think about a bug and the cost of it, if we find a bug early, it means less rework, there's less process to get through, we can iterate very early on. So if we can find bugs of misunderstanding in our conception and requirement gathering, feature analysis, etc., it's very quick for us to just have that. It's often in a refinement meeting, we are discussing those and getting that understanding clearer and just preempting any bugs that may come up before they even get coded or anything in that. From there, we can go into a design phase. I'll go into a lot more detail on how we implement good practices around getting the design phase solid. But essentially it means get your tests in early, test the requirement, like get your tests to test the requirements so that you can then create tests first to then develop code to pass the tests. But yeah, if you fail to do that, as we go through the phases, you'll see that the costs get larger, and this is largely due to the rework or impact to the end user as well. Certainly when you're in production, a bug there could potentially cost a lot more money compared to when it was found earlier on. Right, so on the left-hand side, we've got the traditional tests pass the code imagery of there. So it's where you've got your development cycle. While the developers are going on, you're starting to write tests, but you're relying on the development code to be there for you to really flesh out your tests. And then once the development code is complete or ready for testing, you then start running your automated tests and your manual. And as such, we see the effort at the end. So yeah, that basically means that we're finding bugs later down the cycle because we're in the testing phase, and as you can see, they're getting more expensive. On the right, we have a shifting left method where you can see that we're implementing and writing tests first or much earlier on, and that the code actually has to pass the tests. So this is very much your TDD approach, although I prefer to use ATDD, which is acceptance test driven development. And from there, you're just making sure that your acceptance criteria are being written as tests first, and then your code pass the acceptance tests. There will be more tests than just your acceptance tests, and that is fine. But yeah, it's just those tests will come in as you do your development, but your acceptance tests do need to be earlier on for this to work. And as you can see, due to this, when we're doing all of our work, the cost to fix the bugs are a lot earlier and a lot lower. So yeah, win-win. Going back, it's going to be a bit of back and forth between this from those slides and this one. So here you can see a traditional way of how we used to do development, and also why it is slower. So you can see you've got your blue line of development effort, which very much goes very high early on and then starts phasing out as you get the test phase. And then the test phase in green comes out at the end and starts going up. And we start finding that bug churn, and then you can start seeing the development and the the development and testing phases starting to climb up together. And then we try and release because we think we're of sufficient quality, but we start finding more bugs and we start getting that iterative cycle. And as you can see, this is where you think you've got a feature delivered, but actually the feature delivery is way further on. And then also, this is a massive estimation, but your quality bar, you've not got any tests, you've not really thought about quality early on. So you start off low and you only increment slightly because your effect is being churned out by pressures and rework and that whole cycle. So how can we make it faster? How does shift left testing make it faster? So if we look at making our testing effort early, we start thinking about how we're going to test it, what we're going to test, what are the acceptance criteria that we really need to make sure is there. From there, we can start making sure that we write our test first. Development will then pass the tests. When the development phase is completed, we feel the feature is correct, it passes all the acceptance tests, we can then run it through the CI phase. So therefore the difference between dev phase and test phase is really small because it's all automated. And as such, we fly through, we're happy that we have tested and delivered everything that we expected to be accepted. And then from there, your bugs that you'll find should really be a lot lower. The other really important thing to look at is when we start looking at acceptance tests early, we immediately elevate the quality level. And from there, we get a high bar and we increase as we go forward, which is a way better place to be in, and you actually achieve a much higher quality bar than any other way. So how do we do it? Yeah, we all, it's great saying this all theory, but how you actually implement this within a development team or within a process and that side of things. So really it all starts with the requirements phase. If you get this part wrong, the rest will tumble and fall. So really you need to get the whole team, and a team is the traditional idea of where you've got your product owner, your developers, your QAs, your BAs, anyone who is involved in delivering a feature as a team together. You discuss the requirements. So this might be your initial concept meeting where you just say, right, this is a feature we want to do. The PO or the business person comes in and explains what we're trying to achieve, write out a few things, and then we say, right, let's go and think about how we would implement it. What are some of the design thoughts we need to think about to then come up and start refining. With that, make sure that you're writing up your test cases for requirements. So taking an ATDD approach. Then when you all come back to the refine level, the teams will also discuss the tests as part of the detailed implementation. And if everyone agrees that the tests are correct, you agree that the requirements are correct. And tests are a lot easier to understand the reasoning and purpose of an acceptance criteria compared to the acceptance criteria itself. So yeah, it's from there you're inherently testing your requirements and making sure that everyone understands there's no or very little misunderstanding in that space. At that point, you can also start defining what level and how you'll be testing these. So there may be a unit test, unit acceptance tests, integration, there may be end-to-end. You may even want to implement some manual exploratory testing, that side of things, using the quality intelligence side of it. Absolutely go for it. And then make sure that you have these test scenarios written either on the feature ticket or in a Confluence document or wherever you feel comfortable as a team to have this documented so that you can all hold each other accountable for these tests, essentially. Right, development phase. So I realize I've kind of made a bit of a typo myself in how I've done things, but really I like to take the approach of engineers together will write the tests first before we even start implementing any code for that. This way, what we're doing is we are making code pass tests, not in the traditional way where we code something and we make tests pass the code. It's if we think about it in hindsight, it's quite backward in how that happens. How are you actually proving quality when you're trying to make tests pass something that already doesn't have that quality there? A great idea for this as well to make sure it goes successful is do pairing. Make sure that we are having our acceptance test defining things that have to be there. For instance, if an API, define the new endpoint, define the required and optional fields and parameters. These are things that you can write a test for that you don't actually need the code for yet. When you run the test, it'll fail. That's because you don't have the code yet. Also during this phase, if you have a QA element within your teams, you can actually start planning out any manual or exploratory testing and that side of things to be prepared for when it comes to that point where you need to do that test. And then finished code will run through the CI and the tests have to pass for you to accept it. Next step, that's great. Test phase, code has passed all the tests. If you want to do any exploratory testing as part of like a staging environment or an after development phase, which may be the case, that's great, but you're actually way more focused on what you're testing now. And the time that it takes to do that manual effort is massively reduced as well. And from there, you can get sign off and your confidence is really high. So yeah, end of all of that, really, ATDD, make your tests, then code. Simple message on that side of things. I always like to throw in a testing triangle whenever I do a talk. But yeah, it's yeah, the essential question that I think is being asked as part of this is, well, do we actually still need QA professionals? Well, yes, we absolutely do. Quality or QA professionals are there for that top cloud bit, which is the quality intelligence. Now, that quality intelligence should really cover the whole triangle, because what we're actually doing is we're allowing our ability to think and time to think about how we do these tests. What are we testing? Why are we testing it? What is our process doing? Is it actually fit for purpose? Some of these really complex human-only capabilities that we have. So something that a machine or AI well, I say never, but it's very unlikely to achieve. And certainly on the AI side, we're far away from that ability anyway. And also it allows us to have some non-functional considerations. So performance, security, things like that. Yeah. So I've touched on a lot of these already, but yeah, what are the benefits? I mean, there are a lot of benefits, but one of the big things there is speed. I estimate, and this is going from experience working with a few teams now, that you can actually half your delivery cycle time easily by taking this approach. Yeah, but just by nature of it, you're delivering things much faster and you don't have the churn. So therefore you are getting things out the door a lot faster. I've seen it actually go even more than halving the time, which is pretty spectacular when it happens. Yeah, a green test, we understand what we're delivering. There's very little chance of people saying like, oh, I didn't understand what the criteria was. I didn't know that's what you meant. I mean, a test will very quickly tell you if what you put down as requirement is actually the requirement you want. Yeah, and it also encourages you to think more about the solution. You also know more about the test and what you're testing, why you're testing it. You start reducing the risk side of things. Yeah, I think the biggest thing here is just a massive step up in quality. And that quality with faster speed is something that is very, very powerful for any business. Yeah, don't forget to shift right. As well. So with all the focus of shifting left and side of things, you think, oh good, we've done all this, we've delivered, we're done. You're not done. You need to think about what you've released. The whole idea around Agile is to get that fast feedback from your customers. Make use of it. Go in there and say, right, we've delivered a feature. Now start thinking of your monitoring, your BI, alerting, listening to your users, making sure that it's actually value. And if it's not, either can it or iterate to improve it from that side of things. Yeah, with not having a live audience, I think I'll rattle through that a lot faster. So question time. Let me unpresent. Cool. Yeah, got a couple of questions there already. So yeah, I'll go straight into them. So would I suggest this approach for large-scale programs and big organizations, or is this approach more suitable to smaller teams that are co-located? This can work with anything, if I'm honest. It takes buy-in, so you will need to really sell the idea and show them with examples. Just to give you an idea, the slide deck is very similar to what I use within companies that I work at to explain how it actually benefits you. So it takes a bit of work to get the buy-in and get managerial support to make sure that you're doing things effectively. But yeah, I don't see why this can't work in a large-scale, big organization. It just takes a shift in how we approach things. At the end of the day, it's however you are defining your new feature, just make sure you get in there and say, right, what are the tests we're going to do for this? And then start drafting them out before we even say we're ready to pick this up in our next cycle of work. So if we go, given the question, if this is sort of a waterfall type approach, just saying big organization, usually waterfall. But if we take the waterfall approach, as you have the initial draft from the business analyst saying, right, this is what we want to do. Right, let's sit down with the developer and the business analyst and say, right, how are we going to test it? And there's every way you can do that, because at the end of the day, while the developer was coding against that spec, you are probably writing your test to then pick it up in the testing phase. well, we can shift all of that stuff right at the beginning, think about how we're going to test it, probably get the business analyst to start thinking a bit differently about what he's suggested. And they'll probably go to the customer and say, oh, we've had some of these thoughts, what do you think? And you'll have a bit of back and forth. But at the end of the day, those findings will be really quick and sharp. And then we deliver something that the customer really likes. Yeah, really gone over the small side of things. And yeah, it doesn't have to be co-location either. I mean, I'm sure this current pandemic has shown everyone how we can really work remotely, and using things like Zoom or Hangouts and that side of things, it shows it's really possible from that side of things. Next one, for automated tests created before deployment, would you suggest to use mocks or stubs? Yeah, so this is a great, I like this question. Mocks and stubs, I mean, it's a topic that often divides engineers, but what I would say is early on, there's definitely a good idea for using things like mocks and stubs, because you don't necessarily have the environment or the facilities to test the full ecosystem. And surely with things like microservices, it becomes even more challenging from that side of things. So I would say when creating your automated tests, make sure you can have the ability for acceptance tests that they can use both mocks and the real services, depending on environment or setup. So have those as configurable inputs. How we currently look at doing this with some people that I work with currently is we have in the microservice, each microservice will actually own their own SDK for mocks, and anyone else who integrates with that can then take that SDK and use it as a mocking system for their own tests when they're working in development. From there, the team that actually owns the service is still maintaining the information correctly. And when you pull in your tests, or if they make a change in their tests and your tests are now failing, you get pretty quick feedback on your development deck saying, oh, wait, we need to make a change, or we need to alert them that they've broken something on our end. And you start getting really good feedback. It almost takes away the need for contract testing to some degree. And yeah, it's just a really powerful way of doing it, keeping the ownership of everything within the teams that own that application and calling from it as you need to. Do your QAs write tests using the same tool as developers and the same programming language? Yes and no. Look, it's the reason I use engineers as a term is because really I'm trying to break down the barrier of QA being the person that writes tests on the later phases and then developers doing the lower stages. There's no reason that everyone can't do everything to some degree. So with the QAs as I have, I call them more SDETs or quality engineers is another term that we use. What they do is they actually work with the developers, and we write tests in Ruby for acceptance tests. But we've also got stuff in PHP unit. We have some Java tests for our load testing. We use Gatling, so there's in Scala. We use Mavel as our front-end testing tool, so that's a codeless automation tool there. So yeah, there's many different things that we all use, and I expect developers to use the same things QAs use, and similarly QA engineers to use the same thing as developers. We have unification there. I mean, there's very little argument or friction, and it starts really helping things. Cool. I realize I'm not ticking these as I'm going. Cool. Would I apply the same practices to your non-functional testing, performance testing, security, etc.? To a degree, yes. Look, as part of your design phase, why are we not thinking about architecture, security, performance? These are things that we should have an idea about when we're starting to think of conception. Will it be thorough enough to have a test waiting for code to pass it? Possibly not. So that's where it takes maybe a bit of bending. And bear in mind, processes are there as a guideline. They're not there as your set rules. You have to abide by these. So taking what I'm saying is, yeah, it's largely my opinion, and these are suggestions that I think that can help, but they may not fit your purpose. So with non-functional testing, yeah, you can start getting ideas of like how many customers we expect using it, how would it impact our current performance, Do we need to think about that overhead? These are some of the requirements I'm going to be looking at from the security point of view. Like a lot, say we've got to get a new registration page, we need to think about how it could be hacked, etc. Yeah, so absolutely, some of the practice. The earlier you get in, the cheaper it's going to be to fix it. So if you start thinking about these ideas right from the beginning, the engineers will already say like, okay, well, these are tests I need to pass. So from a performance point of view, I need it to perform in this way. So they'll start engineering it that way from there. How do you tackle bugs not due to code but environment differences? Right, so yeah, this, in my opinion, is more, so there's two facets to this. One is you could have environment instability, which that is a problem in itself and should be addressed as the problem it is. Start making your environment more stable. There's many tools out there, things like Terraform and stuff like that, and containerization, where it doesn't matter about where you deploy the stuff, it's going to be very similar no matter what. Data environments, that side of things becomes, well, makes it a little bit trickier. I get that. But yeah, trying to get as close to production as you can is always going to win. I mean, they've always said the best place to test is production. It's not always the smartest. But yeah, if you're ever going to want to test exactly what your customers are seeing, we test in the place that your customers use. The other side of it, that bugs that come because of code. Okay, I was more thinking about tests, but yeah. So bugs due to code. I mean, look, code should work in the environment as well at the other side. So I think it is slightly on the code side too, where you should be able to have an engineer spin up an environment and do their own sanity tests around this to make sure that things work. If it's not working because of environment difference, you probably set up something slightly different for how it will be used. So yeah, it's, how would I tackle it? I mean, yeah, I kind of had a long answer to that. I think that kind of sums it up. Feel free to post another question if I haven't answered that sufficiently. When, in your opinion, would be the ideal dev to QA ratio for shift left testing to be efficient, be more agile, and deliver fast without compromising quality? I think it's everyone's responsibility to make sure we deliver together. I don't think putting in ratios or set lines like that will be useful in this case. I really think you've got to be agile about being agile in some instances. So yeah, similar to a thing like a developer could test just as good as a QA could test, provided we have those tests in place. What a QA brings is the quality intelligence. A developer brings the engineering mindset and sort of like really focused concentration into solving that problem. So let's make use of those together, and together we can solve it in whichever way works best. So I'd say just be really flexible on it. Don't start setting yourself ratios and like, you only own this and you only own that. You're a team, you own everything together. So yeah, that way you will naturally deliver faster, and your quality will just increase because you're all of a sudden becoming way more responsible for it. There are companies that interpret shifting left as not needing testers anymore. Yeah, absolutely, I can elaborate on that. So shifting left really should never mean you don't need to test. And I'm taking that in that way because not needing testers means that we're thinking we don't need to test. And that's not what we're saying. What we're talking about is we need to start thinking about how we test, what we test, and when we test it. And shifting left is literally taking that information and putting it right at the beginning, thinking of that up front. So yeah, I think if anyone's saying to you, oh yeah, we'll shift left and we don't need testers, you say, well, then you're not shifting left, you're just deleting test. And it's completely an anti to what they think it is. Yeah, definitely. And as I was saying, the biggest other argument you can put in there is QA should really be about quality intelligence and helping to deliver quality software faster. So position yourself in that way, and we'll start singing more business language than engineer and technical, because that's what we've got to try and bridge the gap between is our really deep technical knowledge, and then the business are just saying, well, I just want this thing fast. So the more you can break down that barrier, the better. How do you convince stakeholders to adopt the shift left approach, and how long did they implement it to provide confidence? So yeah, how do you convince them? Be honest, be upfront. Look, implementing shift left testing will initially look like a slowdown because you're not seeing code first. You're not seeing like the actual feature and everything coming in as soon as you usually are. However, what you can start saying to them is, with the explanation of what's actually happening and the rework and all of that side of things, you can like explain to them, yes, all this upfront effort and investment we're putting in now means that down the line, where we historically see bug fix, and we can't get onto that next feature, that goes away and we can actually get through this, get onto the next feature, and our deadlines will be a lot more accurate. So it really just takes good communication and just really strong openness around it and being transparent about what it means. What does it cost them? But also, what does the benefit do they get from it? And then also explain quite clearly what you need from them to make sure that this will be successful. Because if they don't know what they need to do, they're just gonna be like, okay, you're doing everything, and then you find that everything's falling around you. But yeah, if you make sure that everyone understands what it is, why it is, what's the drawbacks, but what is the value, and then what do they need to do to make it successful, you'll find that it'll be pretty easy to sell it. And then how long did it take to implement and to provide confidence? Well, we did very much a sharp, right, we're going to do this from this one, and we only measured from the new one onwards, or from the new process. And from there, it took no longer than a month to really see the fruits of the labor, where we saw, yeah, maybe MVP was a week or two later, but that MVP was closer to a full feature than it was an MVP that was full of bugs and broken, and we just kept on iterating, and then 2-3 months down the line finally had what we had, a shift left testing approach. So yeah, are there any more questions?
Excellent. Thank you very much for that, Dono. Looks like that's the end of the questions there. Thanks to everyone for their questions as well. So if you do have any other questions outside of this, or when you're watching things back, feel free to drop me a line or put it in the meetup group, and between us, Dono can answer those for you. Again, we'll be sharing the recording from this with the slides via our YouTube channel. I'll get that sent out to everybody this afternoon as well. And yeah, look forward to seeing you all soon. Thanks again, Dono, and take care.
Thank you, everyone.
Cheers, guys.
Hope you enjoyed it.